So, welcome back to my kitchen. Today, I'm going to be giving you a brief talk on energy transfer in ecosystems. Right? And so we're going to look at the movement between organisms when one thing eats something else. Right? So we're going to look at the levels of these producers, consumers, the heterotrophic levels. And so heterotrophy is the term we use for when things are eating each other to move energy. We're going to look at how the energy is dispersed amongst those levels and why most of the energy is actually lost and not utilized. So those are the topics I'm going to talk about today. I'm going to try to keep it nice and short because that's the way I know you like it. So we'll get into it. All right, so to begin with, we are going to define the categories of organisms as we will speak about them in this discussion. And so there are three main categories we'll be looking at, which are producers, consumers, and decomposers. And so producers are the organisms that are able to generate their own energy through inorganic sources. And most of the producers on this planet at this point in time are photosynthetic. They make their energy using the sunlight. Right? And so these are things like plants and algae and lichens and photosynthetic bacteria. Anything that uses the sun as their source of energy. And those are producers. The organisms that need to eat other living organisms in order to get their energy because they cannot make their own are called consumers. And there are a great deal of consumer types on this planet, and there are different levels of consumers. So if you are a consumer that eats the plants, okay, you just eat plants, you're a primary consumer, primary meaning one, first level. If you are an organism that eats those primary consumers, you are a secondary consumer. You're on the second level of eatery. If you are an organism that eats those secondary consumers, you are a tertiary consumer, right? So tertiary is a word that refers to third level of things. Okay? And this goes on and up and up and on and on and up. Okay? And so you have these different levels of consumers. The last group are decomposers. And now decomposers are slightly different than consumers, right? They are also breaking down other living materials or living organisms to get their energy. However, they only do it to dead things, right? And they don't eat the dead things the way that we eat organisms as consumers. They break down the dead things into base nutrients, and that breaking down process releases the energy. Right? And so decomposers don't eat dead things, they break them down. Okay? But to the same goal as eating, where they are releasing the energy for their use so that they can have that energy now. Okay? So we have producers are the first level, we have the consumers who are eating the producers and the other consumers, and then we have the decomposers who are breaking down all of the dead stuff for the leftover energy and returning that dead stuff to its nutrient-based form. Okay? So, like all things in ecology, there is a very complicated relationship between organisms. Right? It's not just a very straightforward interaction. All these organisms depend upon one another. And so the consumers depend on the producers depend on the decomposers, the consumers depend on the decomposers depend on both of them. Right? They all depend on one another. And so when we want to graphically represent this movement of energy through the ecosystem, through heterotrophic exchanges, there are three main ways that we represent this. The first is through a heterotrophic pyramid, right? And at the base of the pyramid, at the lowest level, are the producers. Okay? So there's a large collection of producers. The next level up on the pyramid are the primary consumers. They're the ones that eat the producers. Okay? And now it's a more narrow grouping of organisms. There's less primary consumers than there are producers. Above the primary consumers are the secondary consumers. And again, that box is more narrow because there are less secondary consumers than there are primary consumers. Okay? And this trend moves all the way up the pyramid till we reach the tippity top, which is the most narrow box, and there are far less of those things than there are producers. So the higher you move up the pyramid, there are less of those organisms in existence. So that's why the pyramid is a good shape to depict this, right? Talking about general biomass of the different levels. Okay? And as you move up the pyramid, the energy is moving up. Okay, so it starts with the producers and it trickles its way up through different eating interactions. Okay? Another way that we depict it is through a food chain. So that is just listing the organisms one after another. So I'd start with grass, and then I would list rabbits, because rabbits eat grass. And connecting the two is an arrow, okay, moving from the grass to the rabbits, showing us that the energy is going that way. Okay. Then I might draw a wolf, because wolves eat rabbits, so the arrow would be going that way to the wolf. Okay. And then lions might eat wolves, so I'd have a lion up here at the end of my chain. Okay. And the energy would be pointing towards the lion, because the energy is now towards the lion. Okay. So that energy went from the grass all the way up to the lion via the wolves and the rabbits. Okay. The last format that we typically use is a food web, and food webs are just a bunch of food chains put together. Okay. And so you might still start with that grass, and then you still have the rabbits, but also eating the grass might be squirrels, right? And the wolves might also eat the squirrels, okay, and the lions might eat the squirrels. And so these food webs can have arrows interconnecting different levels. Okay? And so it's a better representation of the reality of the food interactions than as a food chain, because the food chain is too simplified. Right? Because things don't just eat one thing. Okay? When you start looking at the food web, what you realize is that organisms can be different levels of consumers depending on what they're eating at that moment. And so if the squirrel's a primary consumer and the lion's eating the squirrel, in that moment, the lion is a secondary consumer. But when the lion is eating the wolf, that lion is a tertiary consumer, right? And so one organism can be different levels of consumer. 3 types: pyramid, food chain, food web. All showing the same thing, the movement of energy through the eating process. So whenever we move from one level up to the next level, right? So if I got the grass moving up to the rabbit, the producer to the primary consumer, when that rabbit eats the grass, it only gets about 10% of the energy that the grass had made. And when the wolf eats the rabbit, that wolf only gets 10% of the energy that the rabbit had gotten. And so every time we move up a level, we only move about 10% of the energy in that process. So if the grass made 100 units of energy, when the rabbit eats the grass, the rabbit is only going to get 10 units of energy. When the wolf eats the rabbit, the wolf is only going to get 1 unit of energy. And when the lion eats the wolf, the lion is only going to get 0.1 units of energy. Okay? So there's this very, very inefficient transfer of energy going on as we move up the levels of consumers. And this principle is why we see that pyramid shape work out the way it does. That's why there are far less quaternary consumers than there are producers. Because the quaternary consumer is getting so little energy out of that whole process, right? That I can only host a few quaternary consumers in an entire ecosystem. And there's just not that much energy. Most of that energy goes to waste. And so the rabbit, when eating the grass, had to expend energy to eat that grass. The rabbit, through metabolism, wastes that energy as heat, right? So a lot of our energy is lost as heat when we eat food. We don't get all that energy. Okay? And also when we eat food, there's a lot of it left over, right? Like it comes out and we didn't use it. And so there's that waste. Right? When the wolf eats the rabbit, maybe it rips off the head and the head flies off the cliff and down into the river, right? The wolf isn't getting all of the rabbit meat. And then the rabbit meat it does get, it's going to waste some energy metabolizing it, right? And so breaking it down, it's going to waste some of the energy in that metabolism. It also had to use energy to catch the rabbit. And so as we move up, there's less and less energy available. And so it takes so many producers to get the energy needed for a quaternary consumer. Yeah. So that's it. All right. Real quick, talked about some heterotrophic levels. We have producers, we have consumers, and we have decomposers. We represent the relationship between them through pyramids, through food webs, and through food chains. When you transfer energy from one level to the next level up, only about 10% of that energy actually makes it. So there's a huge loss of energy, right? That means 90% of the energy is lost. And so that's why any given ecosystem can only hold a certain amount of higher level consumers. You have a lot of producers, you have a lot of primary consumers, but the higher you go up, the fewer and fewer of those types of organisms you're going to see. Okay? And so a lot of that energy is wasted through metabolic action, and a lot of that energy is just wasted through literal waste. And yeah, that's it. Bye.